Hey everyone, welcome to Demystifying Maths at Virtues Institute with Dr. O. Today, we will explore in part 1 simplifying surd expressions. Surds can be simplified if the number in the square root symbol has a perfect square number as a factor. Put another way, you simplify surds by splitting into factor pairs with the largest perfect square number. Sometimes, students make mistakes when simplifying surd expressions. But don't worry, by the end of this lesson, you will become confident with simplifying surd expression. If this is your first visit, remember to subscribe to Virtues Institute channel for more math tips, clear explanations, and upcoming topics. Let's express square root 12 in the form of a multiplied by the square root of b, where a is the number outside the square root sign, that is the coefficient, and b is the number inside the square root sign. To simplify square root 12, first find the factor pair of 12 that contains the largest perfect square. The factor pairs of 12 are either 1 times 12, 2 times 6, or 4 times 3. The largest perfect square factor is 4. So we use the pair 4 times 3. Now, using the surd rule that the square root of a product equals the product of the square roots, we write the square root of 12 as the square root of 4 multiplied by the square root of 3. Next, simplify the square root of the perfect square. The square root of 4 becomes 2. Leave the non-perfect square 3 inside the square root. Thus, the final answer for expressing the square root of 12 in the form a square root b becomes 2 square root 3. Remember, when simplifying surds, look for the largest perfect square factor inside the surd. The perfect square factor can be taken outside the square root. Numbers that are not perfect squares stay inside the square root. Always simplify the surd as much as possible. Let's look at another example. To express square root of 8 multiplied by square root of 6 in the form of a multiplied by square root of b, where a is a number outside the square root sign and b is a number inside the square root sign, using the rule that the product of two square roots equals the square root of their products. The square root of 8 multiplied by the square root of 6 equals the square root 48. Now, find the factor pair of 48 that contains the largest perfect square. The factor pairs of 48 are either 1 times 48, 2 times 24, 4 times 12, or 16 times 3. The largest perfect square factor is 16. So we use the pair 16 times 3. Again, using the Surds rule that the square root of a product equals the product of the square roots, we write the square root of 48 as the square root of 16 multiplied by the square root of 3. Next, simplify the square root of the perfect square. Square root 16 becomes 4. Leave the non-perfect square 3 inside the square root. Thus, the final answer for expressing the square root of 8 multiplied by the square root of 6 in the form of a square root b becomes 4 square root 3. Remember, when simplifying Surds, look for the largest perfect square factor inside the Surd. Perfect square factors can be taken outside the square root. Numbers that are not perfect squares stay inside the square root. Always simplify the Surd as much as possible. Now it's your turn. Using the skills you have just learned, simplifying Surds expressions in the form of a multiplied by the square root of b, using the Surds rule that the product of two square roots equals the square root of their product. Have a go at the practice questions on the screen. Leave your answers in the comments, and if there is any part of simplifying Surds expressions that you are still finding challenging or tricky, drop your questions in the comment section too. Virtues Institute will use your responses to offer tailored support and shape future lessons around what you need most. Don't forget to subscribe for more math tips, clearer explanations, and upcoming topics. Virtues Institute is really looking forward to hearing from you.